So what we're going to talk about today is I'm going to take a little bit of a deeper dive into some of the internals of the framework, specifically to cover areas where we get a lot of questions on the forums, to try and clarify some of the areas and to explain some of the mechanisms and how they work and why they work that way. Before I do that, this is the new Spring Stack. You've seen this picture many times. So we're going to, it's mainly going to be that demonstration. I got like 3 slides and then we're done, and I'm just going to go straight into the IDE and do some work. So what triggered this is, we're getting some interesting questions on Stack Overflow. How do I do this? Why do I do this? And on our forums. But before we dig into that, I'm just going to have a very brief overview of what's in Spring Integration 3.0, and just a bit of a discussion about versions and how we're going to move forward. We released 3.0 M3 on Friday of last week. I'm anticipating a few more weeks we'll have a release candidate, and then probably a GA a couple of weeks after that. So the window's closing in terms of functionality that we're going to get into 3.0. So I encourage you, if you've got your pet Jira out there that you are really interested in getting into this release, then go and vote them up. So that being said, what's in there so far? We recently added, particularly in M3, and we'll see this in my demonstration, the ability to actually add SpEL functions, custom SpEL functions to all the expressions used throughout the framework. You may or may not be aware, but over time there have been some inconsistencies on how SpEL works within Spring Integration. Like once in a while, we'll come across a case where you can't use an @bean, you can't use a bean reference in a SpEL expression because we hadn't added a bean resolver to the evaluation context. So one of the things we've done now is we have a factory bean that all SpEL evaluation contexts throughout the framework are centralized into a single place. This has given us the ability to customize those evaluation functions, those evaluation contexts, in specifically to add things like custom property accesses, which is a fairly advanced technique for dealing with classes that don't fit the normal model. And but the SpEL functions one is quite interesting. We have a new JMX mbean tree poller. Those that are familiar with the JMX adapters, we have an attribute polling adapter that will go and poll JMX attributes and produce a message from them. This new mbean tree poller, you can give it a query and filter, and it'll actually go and pull down a whole bunch of mbeans, assemble them into a map of objects and attributes, and then send them off to a thing. So if you want to do some kind of remote monitoring, maybe every few seconds dump some statistics to a RabbitMQ queue or something like that, then that's a great adapter for that. We have a new file tailing adapter. I'll be honest with you, it's not. It's okay on operating systems that have a native tail command, like a Linux or a Mac OS X, but on Windows we fall back to using the Apache Tailor class. We have a syslog adapter, so we can receive UDP and TCP syslog events. The TCP module now emits events whenever a socket status changes, so we get a new connection or a connection breaks. We now get application context events that are generated. And in fact, we also added a TCP connection event inbound adapter that specifically is configured to receive those events and generate messages. This is pretty important for people who need to have more control over the actual connections. Prior to this, you're pretty much at the whim of the framework. When you send a TCP message, we make the connection, but there was no way for you to know what's going on with the underlying connections. One of the things that, for those of you who've been using Spring Integration for a while, is we started off with the concept of a chain of endpoints being a black box. So the idea is a chain is really an element, and there are some sub-elements within that which you really don't need to know about. However, over time, we've found that was a bit limiting for various people. Things like people wanting to get a handle, wanting to get a reference to one of those inner chain elements to change its configuration, for example, on the fly, or to get visibility over JMX to what's going on in a particular element within a chain. So with this release, we now allow you to add an ID to the elements that are within a chain, and we'll see that again in my demo. And it now basically gives you the ability to do those things. Get a reference to the bean, it's registered with the bean factory, and see those beans as JMX objects. As part of that, I mentioned TCP connection events. Another issue that came up, and then this is all community driven. What happens if I've got this IMAP idle adapter and it can't connect to the mail server? Well, it doesn't generate, because there are no messages, there's no way for the application to know that it can't connect to the mail server. So now, if that problem happens, so if the thread within the IMAP idle adapter cannot connect to the server, then we generate an application event. I think was mentioned in the Reactor talk yesterday, the JVM UUID generation is very expensive in terms of costly, and so if you've got a very high volume, we've found that using a third-party ID generator, which is basically a time-based UUID for the IDs, gets some significant performance improvement. Another TCP improvement. Several people have asked previously. TCP itself has no structure. I mean, okay, if you send an HTTP message, you can put headers in it. You can put x dash blah 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 headers. There's no structure, no standard structure on streams of data that go over TCP. So, to date, or prior to 3.0, you couldn't send any header data. There was no way to map headers. So we've now implemented a mechanism. It's a little convoluted in terms of there's a two-stage step to map the message to something that can contain headers, and then perhaps you do a serialization to JSON or something like that. So that's another feature now. You can configure the TCP adapters to transfer headers. One big change. Now those of you who've been around for a while, we're very wary about making breaking changes, things that might break existing applications, and we do keep the migration guides up to date when something like that happens. This outbound gateways require reply. This is probably one of the most second or third most reported questions. Why do my gateways time out and I don't get any messages? Right, because the default behavior for most of the outbound gateways is to give up silently. So if you've got a JMS outbound gateway and a reply doesn't come on the reply queue, the gateway times out and there's no notification to the application. It just if you run with debug login, you'll see no reply received for such and such a request. It's a little bit. So we've reversed that now. That by default now we've added a requires reply attribute to all of the outbound gateways where appropriate. There are one or two exceptions, and so now now it's actually set true by default in most of those gateways, because it generally makes sense. If you're doing a request reply, then you're expecting a reply, and if you don't get a reply, then you'll get a requires reply exception if that timeout occurs, for example, on the JMS. And then the other breaking change, could be considered breaking change, is similar to that in that the messaging template, when it sends to a publish subscribe channel, if there are no current subscribers on that publish subscribe channel, that channel returns false in that it says we didn't send it to anybody. It's not considered an exception, it just says we didn't send that to anybody because we didn't have any subscribers. And that's considered okay if you think about it in the JMS paradigm, where a queue is something where somebody eventually will get it. But if you send it to a topic in JMS, by default, unless you've got a durable subscription, the model is if nobody's subscribed to that topic, it's just discarded. So that's why the publish subscribe channel was designed that way, to basically say it's not really an exception, it's just the message wasn't sent anywhere. But with 3.0, but when the messaging template is used to send a message to that, if it gets false back from the send, it throws an exception, which is a little, it's not consistent with that discussion about sending to topics. So now, starting with 3.0, if you send a message to a publish subscribe channel through a messaging template and there are no current subscribers, you won't get an exception. You can change that. There's a new attribute on the pub sub channel, minimum subscribers, which you can set to 1, and then that will revert to the existing behavior where you get an exception. But it can also be used, you could set it to 3. So if I don't send this to at least 3 subscribers, then that's considered an exception. So that's just a sort of quick overview of 3.0. I just want to have a quick mention of versions. Anybody seen or heard? There was one session this morning that mentioned it about Spring 4.0 and some of the core Spring integration concepts like message and channel are moving into Spring. Is that anybody familiar with that? Okay, at least one. Okay, we have a few. So it makes sense to do that because we don't want to have the core Spring framework dependent on one of the sub-projects, Spring integration. The WebSocket stuff that Rossen did required some of these same abstractions, messages, channels, etc. So there's an area of confusion now. If somebody's actually using Spring 4.0 with Spring integration in their IDE and they type in message for auto-completion, they're going to get 2 messages are going to show up. Right, the Spring message, if they've got Spring and Spring integration on the class path, and the Spring integration. So the plan is as follows. We're going to, soon after 3.0 is released, and actually in parallel with 3.0, we're going to have a Spring integration 4.0. It's sort of happenstance that the numbers all work out, but the idea being that we obviously cannot force people to move to Spring 4.0, and I'm sure a lot of people wouldn't be able to do that when using Spring integration 3.0. So the plan is that we're going to have a 3.0 and a 4.0 Spring integration streams that are pretty much identical, just that the 4.0 Spring integration will have the same functionality as the 3.0. It's just that it will use 4.0 Spring Framework 4.0 as its base, and it will use its abstractions for messages and channels. If you are using Spring 3.1, Spring 3.2, then you would use Spring Integration 3.0. Spring Integration 3.0 will still work with Spring 4.0, but you'll have that confusion of two messages and two channels. So that's the general idea. We'll have 2 streams, 3.0 for people using Spring 3.1 and 3.2, and 4.0 for people who are ready to move to Spring Framework 4.0. It's very likely we will continue to move both. I mean, there'll probably be a 3.1 and a 4.1, which will be in the same vein. And then eventually, sometime next year, then 3.1 will go into a sort of maintenance mode, and 4.0 and above will be where we do the new work. And the last thing I just want to say about versions is, if possible, please try and keep up on the latest version of a particular minor release. A couple of occasions recently where on forums or Stack Overflow, people have said, I'm having such and such a problem, and I have to ask what version you're using. That's another thing. Please, when you post things on the forum, remind us which version you're currently using, because it saves a lot of time. But they're using 2.1, 2.10, right? Well, 2.10 is sort of getting a bit dog-eared. It's nearly 2 years old. So it turned out that particular problem has already been fixed in 2.13 or something like that. So just another heads up on version. And any questions on just this very quick sort of overview before we dive in? Okay. So What I'm going to do now is just go through some basic concepts. Some of it will be old hat to some of you. Some will not know what's going on, but hopefully, as we move on, we'll expose you to some things that perhaps you didn't understand or didn't know how it worked. I'm going to try and remember, and if I forget, please remind me. As I go through each phase of this, I'm going to make a new commit. So I'm going to basically work with a blank page, add code, go through some samples, and each time we get to a phase, I want to make a commit into GitHub, into the Git repo, and then when I push this all up, probably next week sometime, there'll be a complete history of the of this work that we're going to look at now. The other thing I just wanted to mention is I'm starting here with a simple gateway where I'm just going to use a test program to invoke a gateway and launch a Spring integration flow. All of this stuff applies. What I'm going to talk about applies to any inbound gateway, whether it's HTTP, JMS, what have you. So let's do just that. First thing I want to do is I'm going to create I have a basic interface here, and I'm going to have some method on here. Let's just have something that returns a string. Single. This is my gateway interface. Is there anybody here not using Spring integration right now? Okay. A gateway is typically, or it's one way of invoking the messaging system. The idea is that we don't, the application that's using messaging shouldn't need to know that it's using a messaging system. So in the way that gateways work in Spring integration is all you define is the interface. Spring integration provides the implementation to build that gateway into the messaging system. So I've defined my interface. It's just got this single method on it. And let me close some of these windows. And I'm going to take my application context here, and I'm just going to define a gateway. Gateway. First thing, as we all know, we need to give it a service interface, which is my service. And there's a couple of other things I need to do. First thing we need to say is where are we going to send messages by default? And we're going to send them to, let's say, a channel called in. Now I'm going to jump down. There's some stuff here for later. So I'm just going to define a chain that does a couple of things. I'm going to add a transformer. And it's a pretty simple transformer. It's just going to add the string hello in front of our payload. So the idea is with the gateway, we're going to send it a string, and now this transform is just going to stick hello in front of it. Now I'm going to add another step. I'm just going to add a service activator. And in this case, it's really only going to be doing a transformation, but I'm going to call it a service activator because typically you're going to do some processing. So first thing I'm going to do is I'm going to make this groovy so that we can do something a little more interesting. I'm going to put a groovy script in here. And let's say we're just going to do some print line. And the new payload. And for now, I'm just going to upcase the payload. And that's all I'm going to do. So we've got this simple service. Our calling program doesn't know it's calling Spring Integration. It's just going to invoke this gateway. The gateway is going to put a message on this this channel. And within that chain, the message then is going to go to this chain. We're going to transform it. We're going to add hello, and then we're going to upcase it. So let's just take a look at let's write a test to actually invoke this. Let me fix this. So I had a test. And I'm just going to sys out the result of calling service.single with a value foo. And we didn't get it. Let's see. What did I do? Okay, I didn't close my transformer. Oh, that's why. With SpEL, now this is a SpEL expression, so this is basically I need this literal hello, and then I'm appending this variable payload. As we'll see in a bit, with that new SpEL function stuff, we can add functions to that. So let me run it again, and now this processing hello foo came out of our service activator, and then in the console down here we got back hello foo, because you remember I just sys out the result of calling service single. Now, one of the things I want to show you now is some of the internals. So I didn't. Excuse me? That's one of my topics. Okay, so there is if you don't define the channel for the in, then the framework will automatically generate a direct channel for you. If you want to change the type of the channel, you want it to be a pub sub or a pollable channel of some kind, then you have to explicitly declare it. But if you're happy with it being a direct channel, then you can just you can just let the framework declare it for you. As you'll see in a minute, I'm going to turn it into an executor channel, in which case I will have to add that. So let me run this again so that I get something in my log, and so I can show you what I want to show you. Now, and this is another just while I'm scrolling here. Another very common question is, I did this and nothing happened, right? What's going on with my application? Well, in many cases, and if any of you follow my forum posts, one of the first things I always say is turn on debug logging, right? Turn on debug logging. We do copious amounts of logging. Pre-send on channel, post-send on channel. Just turn on login and look at the log, and most times you'll see what's going on. So what I want to show you here, though, is here we have this pre-send on channel. If I can highlight that. Now, there's a couple of key components in here. You can see this last attribute here is replyChannel. The last header is what did I do? I hate Macs. Here we go. So we have this replyChannel, which is a org Spring framework messaging template temporary reply channel. This particular instance. Now, whenever we send a message to a gateway, the gateway is going to create a temporary reply channel that it's going to wait on to receive the reply. You'll notice also that the error channel, if you actually look at the idea of this class, it's the same thing. The error channel is exactly the same as the reply channel, and I'll explain why that needs to be in a case. Now, this reply channel is, as I said, where the reply goes to, and you'll notice in the application context here, I didn't put an output channel on this chain, and so when the chain ends, when we've processed all the components in the chain, we send the reply to that reply channel, and when the thread finally goes back to the reply channel, we had a successful send, we then will do a receive on the reply channel, get the reply, and return it as the result of the object. Now, let me make something fail. So this is groovy. So I'm going to say something like, if payload equals bar, so basically, I'm now going to throw an exception if we send a bar, a payload containing bar. We're not going to complete. Now, if I go back to the test case now, I'm just going to do a second call on this gateway method. Anybody guess what's going to happen when I run this? Excuse me?
I think you're going to receive an exception in your method.
Correct. Yep, because as I said, it's direct channel by default, which means it runs on our thread, and sure enough, see, that's because, remember what I did before this. I said I've already transformed it to hello plus bar, right? So, no. I'd like to say I did that on purpose, but all right. So now I've just said if the payload equals hello bar. So now we get our exception. So what's interesting though is it's a runtime exception, right? The actual exception thrown by the downstream element, although it's running inside of a messaging exception, and if you look through all the logs, you'll actually see a messaging exception was thrown with that runtime exception as the cause. But as I said when I started with the gateway, we don't want the caller to even know he's running in a Spring integration environment. So he's actually going to get back the original exception, the wrapped exception, this runtime exception. So how do we solve that? Yep. Now the error channel is basically like the catch block in a try. So it's like, you know, if the send fails for some reason, then we're gonna catch it. Now, by default, the framework provides you with an error channel called errorChannel. It is a publish-subscribe channel. It will send the mess and the publish-subscribe channel, so you can subscribe to it. But we automatically subscribe a logging adapter to it. So you could actually go in now, and we could see the log here somewhere. If I get, we can. Here's the logging adapter. Is logging the exception with this. There we go. Error, right? message handling exception, failed to execute script. Now, what happened to our request though? I mean, this thing's still running, right? So, because the default error channel is just sent to a logging adapter, that just goes. That's a one-way integration. It writes it to the log file, and no reply comes back. So now our original thread is sitting in the gateway waiting for its reply. You know, that reply channel that it added to the message is never going to get a reply in this case. So there's a couple of things you might want to do there. One is, I'm going to have to stop this, right? One thing you can do is add a is add a reply type. It's default. Yeah, default. The reason these are default, and you'll see in a minute, is because we can have different attributes for individual methods, and we set defaults at the top level. So one thing we can do is set a reply timeout, in which case the thing will be logged, but we don't get an exception. So by using the default error channel, you get a log, and you just get back null as a result. So it might be useful, might not. Usually, though, what we would rather do is add our own errors, our own error handling, right? So I've just added this this error handle, this thing. So I'm just going to add another transformer. Again, I'm going to cheat and just say the input channel is errors 1, and I'm just going to put expression equals. Now I'm going to give it a literal failed. Yeah, I got to. Expression equals failed plus. Now, the message that goes on an error channel is an error message, and the error message payload is a messaging exception, and the messaging exception has got two attributes: the failed message, the original message that failed, and the let me close down my the failed message that failed, and the original exception. So I'm going to say here, okay, well, my error handler is going to say, I'm going to return a value now, failed, and I'm going to say the payload, which is the exception, failed message is a property of the exception, and then its payload. And I'm also going to add the exceptions message. So I'm going to say payload cause message. So this is all SpEL. This is just standard, bean lookup. So that's really calling payload.getCause.getMessage, and this is calling payload.getFailedMessage.getPayload. So now our error handler is just basically going to say, okay, I had an error. I'm going to transform it into something else and return that as a reply. Save that and run it. And sure enough, we got failed, hello bar, fail, right? Hello bar, we did a transformation from bar to hello bar. The exception message is fail, and we just added we preceded it with fail. Any questions about that? Is everybody sort of still with me? Okay. So one thing that, well, actually no. Let me go to the next step. What happens if we go async, right? Think about what's happening. It's a direct channel. The calling thread called the gateway. The gateway put the message on a direct channel, which means it runs on the same thread. We called all the chains and all that stuff. We ended up sending a reply through all this error handling to the reply channel, and then when when that thread then came back to from processing all that, it then read the reply channel and returned the response. Well, what happens if it's not a direct channel? So let's turn this channel into an executor channel. So, and we all know the way we do that is, I now do have to explicitly give it a declaration. And to make something an executed channel, which basically says run it on another thread, is we add the dispatcher and we just add a task executor to that. And I just need to add a task executor to the context so that we can exec. So all I've done, and this is one of the, a couple of people were asking me this morning about, I mean, Spring integration. One of the real power here is that the channel is a full first-class citizen in the environment. So you can just go in and change the channel definition, and it. Oh, sorry, should be in. Thank you. By just changing the channel definition, we're changing the way that the various components are being invoked. So now this is what's going to happen. Now you think about what's going to happen now. That the calling thread is going to call the gateway. It's going to call it's going to basically put the message into this executor's execution queue and then return back to the gateway and wait for a reply. The executor goes and does his thing, sends his reply, and then the initial thread will continue. Yes.
Actually, just a quick question from before you made that change.
Yes.
If we're in the single thread of execution and you have that timeout, and what's receiving the message is really slow, and the timeout expires, will it actually time out back to the original? What it was doing.
Good question. You get a book for that. The timeout will actually, well, the timer will begin when the thread returns to the gateway. So, yes, if it runs and then it's actually stuck in some downstream environment for 20 minutes, right? But eventually does return, then the timer is started, because it's at that point that we try and receive from the. So the reply timeout is initialize. The clock starts when we try and receive the reply. But yeah, good question. But the reason I want to show this is what the interaction is with those headers. So I'm going to run it on our. But everything works the same way, works just fine. And if we look at the log, we'll see that the wish I had bigger. So we'll see here that the presend on channel in is on the main thread. Now we know channel in is an executor channel. Am I looking at the? I think I might have gone back to. No. Man. Did I? I'm gonna have to shrink this down a bit so I can see what I'm looking at. Yeah. That's way too small for you guys, right? Let's see. Good. Good for you, and maybe not the guys in the back. So what I'm trying to whoa. Oh, my screen's all. Looks like changing that is messing me up. So let me. You know what? Let me open it in a text edit. This will be easier. All right. So what I'm trying to show here is the okay. So this main thread did a pre-send on channel in, and immediately did a post-send on channel in. So we've sent the message to the channel, and then this exec, the task executor, picked that request up and actually processed the message. But as we can see in the message, as I mentioned up front, the error channel header and the reply channel header are the same thing. Let's think about why that's needed. First thing to understand is that when we run a inject a task executor into the channel, the task executor gets wrapped in what we call a message handling task executor, and the error handler in that error handling task executor is a message publishing task executor. So the way that mechanism works is now we have this asynchronous thread that's doing its work, and it throws an exception. Well, what am I going to do with that exception? It catches the exception and it sends it to the error channel that's in the header. Now, if it just sent it to the error channel, the actual error channel that was on the gateway, we've got a disconnect, because then how do we get hooked back up into the gateway again? So the reason we send it back to the gateway's reply channel is then the gateway can see, the message I got was actually an exception. The reply I got was an exception. So then he can send it on the real error channel. Then when the error channel processing completes, if it completes normally, the reply is sent to the client. You say, well, why couldn't we do that in the task executor thread? Like it's got both the channels. It's got the error channel and it's got the reply channel. So why don't I handle it in there? Well, the problem then is, what if the error flow throws a second exception? So it just gets very messy. So the reason that the error channel and the reply channel are pointing to the same temporary channel is so that we can get it back regardless of whether whether we have a real whether we're using an executor or not. Any questions on that? Okay. Now, one of the things that another area of confusion that comes up a lot is notice I haven't done any reply channel here. Everything is just using that inbuilt header that's within the reply channel. So why wouldn't I do something like this, or why don't I do something like this? Let's say I could just say default reply channel is replies. And I'll just change this to say output channel is replies. Why don't I just do that? I mean, you can. It's perfectly reasonable to do that. It's just that it's not necessary, because it's exactly the same thing. What happens is the framework will indeed send it to replies, but then inside the gateway, replies gets bridged back to that reply channel header. That's why you get those infamous messages. There is no reply channel header in this message. Just sending an arbitrary message to this reply channel that's sitting on the gateway isn't going to do anything because the gateway needs to correlate the reply and send it to the right thread. And that correlation is achieved using that reply channel header. So it's not this adding a reply channel here is maybe it provides some syntactic sugar where okay, I know where my reply is going back to, but it doesn't really add much value. The one area where that's the case, that's not the case though, is if you want to do something something else with that reply. So let's say I actually want to make my replies channel publish subscribe, and I just want to add a logging channel adapter to that channel. So, or you want to add a wiretap, or you want to send another copy of it to somewhere else. So you actually want to see the reply, because in the default sense, it's all done internally within the framework. The reply just gets sent back to the gateway. So by adding this pub sub channel, the replies is now a pub sub channel. Yes, I can explicitly send the replies, and we're now able to get access to that reply. And sure enough, if I run that, everything works as expected, and if we can see the log again, we should actually see the log of the reply as well. Where are we? Post send on error. There's a Well, it's going to take me too long to find it, but that's basically what's happening, is that the reply goes to the pub sub channel, and it's going to go to both. Of course, that's why I didn't see it. I said, yeah, my notes, I said, in order for this test to work, I need to remove my exception, of course. We actually want to send a reply rather than throw an exception, right? There's no reply coming back from the chain at that point. It's coming back from the gateway. And that's still too far. Anyway, trust me. So that's some basic functionality. Now let me sort of take this a step further. Now let me undo these. I'm going to put that exception back in there. One of the questions we get asked a lot is, what if I have an existing interface that takes more than one argument? How do I use Spring integration without having to rewrite my client, without changing my interfaces? So we have a fairly simple way of mapping parameters to gateway methods. I'm going to add another. Method to my interface here, and I'm just going to have. I'm going to add 4 parameters. One. I'm going to go to my test case. I'm going to ignore this for now because I don't want to fill up the log with his things. And I know I've already forgotten to do my commits into GitHub, but I'll. So I'm now going to do another test. I'm just going to do. Let me do a object out equals. Service multi, and I'm just going to go foo bar this resolution's too small. Yeah, thank you. So now I'm gonna send these 4 arguments to a service. So how am I gonna map that to? Now we've had some thoughts about how to provide a excuse me one sec. To provide a more flexible way of mapping arguments, but it's reasonably flexible now. But you just have to use SpEL expressions. So as I mentioned, this gateway is set up with a bunch of defaults. But now I can add a specific method child element where I can say, well, for this particular method, I want to use something different. So first thing I'm going to say is method name equals multi. I'm going to say, let me put this on a new line. A new string array consisting of args0, args1, args2. So what this is a SpEL expression. We've made the arguments a what is that complaining? Well, what I'm going to do with the 4th one is just to show you what else we could do is I'm going to add that as a header. So I'm going to buzz. Just want to see what have I typed wrong in there. Oh, payload expression, of course. Duh. So what this is going to do now is basically take our method. Now, obviously, that existing chain is not going to work because remember our first transformer does hello colon then payload, and then we do things like to uppercase. We can't do an to uppercase on an array. So what I want to do is I'm going to add a splitter. So I'm going to take off the. Let me get rid of this executor channel. Go back to a regular channel. But I'm going to add a splitter. And input channel is in, and the output channel is channel 1. I'm going to call it. Now our chain is going to listen to channel 1. Anybody know what's going to happen now? Right. It's basically going to split that array that I created in the SpEL expression into 3 single messages. Now, once we split it into 3 messages, we can't send 3 replies. I mean, the gateway is a request reply. It's expecting to get 1 reply. So typically, in a typical pattern, it's not the only one, is we would add an aggregator. So now our channel is going to now get these 3 split, it's going to get foobar bars as individual messages. It's then going to send them to an aggregator. And again, in this case, the default aggregator is all we need because all the headers and everything are set up for us. And the input channel is our aggregated channel. Again, I'm not going to give it an output channel because it'll go back to the gateway by default. So if we look at that in the graph, the gateway sends it to in, it goes to a splitter, We go into this chain, which does transformation, service activator. We go to the aggregator, and then it goes back to the gateway. And before I do that, I do want to comment out because one of our arguments is bar. If you remember, I'm sending foo bar baz. So this would kick in on the second message. So let's just run this without any exceptions. Oh, what did I do? What? Oh, of course. Oh, exactly one of value. Oh, I got the header wrong. Did I give it a name? Oh. Of course, I got to tell it that we need to use args3 as our header. So we run that, and we're just doing a. Oh, I didn't because I didn't do a sysout, so I'm going to do a. Sysout of out, and we're going to get back it. So we'll see the 3 processing messages, and we'll get back the a collection of these uppercased prepended with hello foo bar baz. Now, any questions about that? So we sent an array. We used SpEL to convert our 3 expressions into an array. We happened to put the 4th argument in as a header. You want to see the header? Sure. So pre-send on channel in. So am I at the? Yes. What? Sorry. This is old. Oh, my logs rolled over. I know what I want to do is I'm going to remove that baby. Let me run it again. Run it again. And you can see in any of the this buzz equals quox header, so we could use that anywhere in the framework later on, or in your application. Now, okay, pretty simple. We had an array of strings. We split them. We sent them through the processing. We aggregated them back into a collection of results, and we returned that to the gateway. And what happens, and this is a book prize, what's going to happen if we throw an exception on the second? Now I've got an error handler, right? No, I don't do it. Yeah, I have an error handler. I'm going to send a message to errors1. If the second of those 3 splits, remember it's all on the same thread, the second of those 3 splits throws an exception, what's going to happen? Excuse me? Next. Okay. Any more? I get which? Any more? No. Nobody gets the book. Look what happens. I process foo, I process bar throws an exception. The result that we get back is the error for the second one. The first one is still sitting up there in the aggregator, waiting to be aggregated, right? And it's going to wait there forever unless you've got a message group store reaper there that's going to clean it up, right? So this particular thing came up on the forum a couple of months ago. This is a real case environment where he had a bunch of messages. He wanted to aggregate them, but he had an error in the middle. And so we're partially, what do we do? What do we want to do? Well, you have to decide what you want to do. Maybe that's okay. Maybe that's the expected result. But in this particular case, no, he wanted to handle it a little bit more elegantly. So let's see how we would do that. Make sure how my time's going here. We're doing good. Yes? When we split, the headers are basically replicated across. There'll be some things different, like the timestamp, not the timestamp, the ID will be different, but the rest of the headers are basically copied. In fact, that's a very important point, because when we aggregate at the end, things like the reply channel, if you mess with the reply channel, when we aggregate at the back, if he gets a message that doesn't have the same reply channel, we'll end up tossing both reply channels, because it says, the aggregator doesn't know how to mix headers now if they all have the same values, then the final aggregated message will have that. But we'll see that a little bit in a while. So let's any more questions? Because this is a fairly common problem, right? How do we do error handling when we've split into multiple messages? This would be exactly the same way whether this was a task executor as well. So let's see what the solution is. Make sure I didn't miss any steps. Okay. The solution is a fairly interesting technique of basically adding an error handling gateway mid-flow. So what I want to do is, after the splitter, I'm going to add a service activator. Input channel equals channel 1, and it is going to invoke a gateway. Now the gateway doesn't have any service interface, we just use the internal service interface. He has a default request channel, which would be the chain, so I'm going to have to give the chain a new channel. And of course we don't want the chain outputting stuff to the aggregator, we actually want the aggregation to come from our service activator. So I'm going to put I'm going to send the result of invoking this service. So now let's think what's going to happen. We go through the splitter. The splitter then invokes each individual split message calls this service activator, which in turn calls a gateway, which then calls the chain. So you might say, well, why add those two steps in there? Well, it's like adding a try-catch block inside of a bigger try-catch block. Remember I said the error channel is like the catch block on the inbound gateway. Well, we can simply add now on this gateway, we can add an error channel element, and I'll just call it errors 2. So now if any individual message within this subflow has an exception, that will now get sent to this errors2, and if that's handled appropriately, it can then return, and so the gateway, what's going to come back to the aggregator, is the result of that failure. So let's, basically I'm just going to replicate this transformer. I'll call it errors2. And I'm just going to call it partially failed. Split messages go through this error handling gateway. The subflow is invoked, in this case, this chain. The result of invoking that chain goes back to this error handling gateway. If it's a good result, it just goes back to the caller, in which case it'll get routed to the aggregator. If it's a failure, it gets sent to errors2, and if it handles it successfully, then the result of that error will go back to the client. So now we run the yes.
Can you please go over the flow, because I think there's something wrong with that.
Okay. Oh.
Channel 2 doesn't have anything.
Yeah, I didn't ref it. Sorry. It's my. Let's see. Why is my browser? Oh, let's see. What didn't I do? So I need to ref this to ref equals. So this gateway is my error handling gateway. I'll just call it EHG. And in here, I'll say ref is equal to EHG. Input channels channel 1. So what this is saying is that the splitter sends its message to channel 1. Oh, I need it. Thank you. So the splitter will send it to channel 1. Channel 1 is the input for the service activator, which references the gateway, which then sends it to channel 2. Then the result of the gateway will go back to the service activator, and its output channel is the aggregator. So now if it's a success or a failure, we're going to handle it. And there we go. Hello foo, partially failed, hello bar fail, hello baz. Yes?
Instead of adding the service activator in between, can we not write a custom aggregator which actually handles the error?
If you want, but how much? I didn't write any code there. Yeah, you can write a custom aggregator, of course you can, yeah. You can always, that's one of the beauties of the framework. You can always extend it or do it whatever way you want. Most people find, though, after getting involved with it and sort of like figuring out that, hey, most of the time I can avoid writing any code at all. Maybe a few expressions here and there. Maybe I do some optimizations if there's a critical performance issue somewhere, but no. Is that obvious? Is that clear what's going on there? Do we need to just go over it one more time? It's basically a thing. I always think of it like in Java terms. It's really like putting a try-catch block around some subflow. You're just basically wrapping it in a gateway invocation, and that gateway invocation has then got its own error handling capabilities. 2:00. Yes.
In case that the channel is, with the task executor.
Right. So that's you must have read my notes. Because that was the next thing I'm going to show, is that this works exactly the same even if I make channel 2 an executor channel. Oops. Channel 2, give it a dispatcher. So now within that gateway subflow, we're still handing off to another thread. what happens is our thread is now, instead of waiting back in the original gateway, it's waiting in this gateway. So again, you could put a timeout on here and deal with it that way. But most of the time you wouldn't want to do that. And so we get the same result, whether it's an executor channel or not. So we're hitting up against some time constraints here. Next thing I want to show quickly is, I mentioned it in the introduction, and that is this new feature of being able to customize your SpEL expression throughout the framework. We've now standardized on the way the SpEL evaluation context is made available to every element that uses expression for Spring integration expression evaluation. So rather than write a bunch of code from scratch, I've basically got this simple function. Now, a SpEL function is simply a static method on a class. Okay. So I've got this class called funcs, and it's got this method called foo on it, that all it does is prepend foo to the payload. If you use it, though, it takes foo, adds foo colon to the front of it. So how do we define this how do we add this to the evaluation context of any of the components that are within the application context? We have a new namespace element. Oops. SpEL function. We have to give it a class. Oops. And we have to give it a method, and should only be, the method is foo. And I'm just going to call this function, hey, how about foo? So the beauty of this implementation is we don't have to do anything on the element that needs it. Now, any SpEL expression throughout this application can now use this function internally. So I can change this this transformer. Instead of saying hello payload, I'm going to say hello foo payload. Now, one thing I know I did wrong, and I have to do it here. The way we define the method is we have to give it what kind of arguments it takes. So we have to say Java lang foo takes a Java lang string. Reason we have to do that I think it'll fall back to do that by default. But if you've got multiple methods that have got different argument lists, then you would need to do that. But now, so it's the same syntax as using a variable within SpEL, a pound sign. Like we've got pound sign root. Like in the HTTP inbound adapter, we've got request params and path arguments and stuff like that. It's just pound sign and then a function and then payload or whatever you want in your expression. And excuse me. You can pass in the actual message, but now you can see I've now enhanced these guys. Yes, so every SpEL expression within Spring integration has there are a few exceptions, but in most cases the message is the root or the this variable. So it has two attributes, payload and headers. There are some SpEL expressions like file names and stuff like that, remote file naming, which have different elements. But yeah, I can say foo this. That's actually going to send the whole message into foo. But of course, foo takes a string; it doesn't take a message. So this is sort of a demo by fire, but let's try it. So I'm gonna add another foo. That takes a message, and I'm just going to say foo to string I'm going to import that. And in our integration context, let's see. Just remember what the there we go. Fully qualified class for message is that. So let's so foo now actually takes a message, so you get access to the headers and anything you want in there, and we'll run it, and now we got the full message in there. Does that answer the question? Yes, yep. The conversion service is also available. It's actually a type converter that uses the conversion service as its underlying thing. So yeah. Yes.
If that function returns a message and the thread works like everything else, where it says, "Oh, you returned a message," I'm going to use that as the entire message for the payload.
Yes. Yes. Any more questions on that? I have some more books, so interesting questions earn a book. Yes.
Sometimes we have a chain, and inside that chain we have a lot of service activator method calls. But let's say the second one is a method that is a void, that returns
Yes.
void. So currently the execution is broken. What's the workaround for that?
Well, it's not allowed really, because that's really saying that you've got a chain. If something returns a void, then that's the end of the road, right? There is no message to send on.
Yeah. But for example, I know that a lot of like previous version of string iteration, because right now you can have service activators that doesn't receive anything, like method call that doesn't have any arguments.
Mm-hmm.
And it can be inside of a chain, even though they're not receiving anything, right? So I think that's like equivalent, because what I don't want to do is create a method that returns some dummy payload, because sometimes the service activators are actually method calls that you already have.
It's a thing we've sort of discussed on and off many times about should we have the concept of a null payload, right? So that something can return null and say, if it returns null, I want the message to continue. We don't want null. We don't want a real Java null in the payload, because that would just break a lot of code. But maybe we could have some class of some kind that represents null. And right now we don't have it. We're debating whether we should do that. You could very easily add with the two feature of adding request handler advice. Is you could put a request handler advice around that service activator. Say if it returned void, then return some arbitrary payload that would continue into the next element of the chain. But no, currently that's not supported out of the box, not without some custom code. Yes. Is there support for it for circuit breaker? Yes. Yeah. If you look at the reference manual, let's see. Let me go to Spring IO. This was introduced in let's see. I hate. Why can't I find on here? Edit. Find. Oh. Why can I? Okay, adding behavior to endpoints. So we have three standard advice classes: request handler retry advice, which allows adding retry capabilities; the request handler circuit breaker advice, and just a generic expression evaluating request handler advice. So that has a circuit breaker that says, okay, if it failed 3 times, then hold off, fail fast for the next 10 times, or for some time period, and then reset. So that's in the existing 2.2 version.
You were mentioning that in the Spring you are using some other ID generator.
Yes.
Are you going to show us how it looks like?
I can do that. It's basically it's a third party. It's called EAIO, and what we did is we wrap it into a standard JVM message headers. So if let me see. I'm trying to remember what the core. Yep. Oh. It's funny, I should know this code, but I wrote it. I just don't remember where we put it. I'll look after I can show you where it is, but basically it takes the upper and the lower values and wraps them in a UUID, Java UUID. I will post this sample. I had some like extra stuff that I was going to do if I ran out of time. I was going to add like an AMQP gateway into the middle of the chain and send a reply and get remote stuff like that. I'm trying to think if there's anything else specifically that I wanted to cover. So we're kind of running out of time.
I had another question related to your first comment.
Okay.
What is the justification of pulling the messages in the channels into the core?
The put in.
Why are you guys pulling the messaging channel into the core?
Oh, why are we pulling the channel the message? So the WebSocket work that Rossen did, and use it with stomp support and stuff, that clearly fits in the MVC space within the within core Spring, and so he needed message channel, etc. in that space, and so we can't really have this sort of two-way dependency between core Spring and Spring integration. So we couldn't have core Spring depending on core on Spring integration. So I don't know if you were here at the beginning when I was talking about the 4.0 stuff. The 4.0 stream, the Spring integration 4.0 is going to use those core abstractions.
So I was just thinking that was more justification to split out the things which depend on it instead of putting the core to make it bigger.
We did go through that. You mean actually having like a little tiny module that they both depend on? Yeah, there was a lot of debate by that, but the decision was finally to pull it into core. Yeah. Yes.
What about you have like JMS as your inbound messaging and you're doing aggregation and you have one fail and you need to roll
Well, that just works. I mean, if if you don't have an error handler or an error channel on the gateway, then the exception will get thrown back to the listener container, and the message will get rolled back on the queue and be, right.
Currently, what we're doing asynchronous, message with the task executor. For the error handling, what we're doing is adding for each message, adding the error handler header to
Yeah.
that message, so that any exception will route to the error handler that channel that we define in the header. So what's the difference between this approach and what you're doing?
I would say whenever possible, don't mess with the reply channel or error channel headers. There are rare circumstances where it's best to let the framework deal with those headers. There are cases where you've got an inbound channel adapter it's not a gateway, so it doesn't populate a reply channel or an error channel where you need to enhance. So you've got some kind of inbound, like if we use this gateway thing, we got a message from JMS with a splittable message in it, and we split it. There would be no error channel in that because in the case of that there could be, but the inserting your own error channel is doable and works, but you have to be careful not to break the framework because it's the certain assumptions that the framework is making about that. I would say try and avoid it if possible. But you do get a book for asking. This is written by Mark Fisher, the infamous Mark Fisher.
When we use a splitter, at that time, the messages, how they are arranged actually, randomly or?
No, when the question is when you get a splitter, how are they arranged? Are they random? No, they're just basically broken up and put onto the message in the sequence that the splitter puts them on. Now, custom splitter could sort them, could do what it wants, but standard splitter will just if it's got a collection, it'll just break down the collection and put a message on the channel for each. How are we doing? Looks like we might be out. Yep, looks like we're over. So, well, thank you all. I hope it was useful and. Carry on using it.